This is episode 43 of Ethics and Culture Cast from the DeNicola Center for Ethics and Culture. Welcome to episode 43 of Ethics and Culture Cast from Notre Dame's DeNicola Center for Ethics and Culture. I'm Ken Hellenius, the communications specialist at the center. In this episode, we chat with Steve Barr, a theoretical particle physicist and the president of the Society of Catholic Scientists. In our conversation, we chat about the relationship between science and faith and why people of faith should not be threatened by scientific research. Let's sit down for this delightful conversation. Well, Steve, thank you very much for coming to be with us today.
Well, thanks for having me on.
So tell us a little bit about yourself. Where did you grow up? Where did you do your studies? What have you been doing in the intervening years? Those sorts of things.
Well, I grew up in New York City. I'm from Manhattan. Grew up in the Columbia University area. I actually went to Columbia as an undergraduate, did my PhD at Princeton. And that was 41 years ago, going on 42. So I've been in physics for a long time. Did a postdoc at Penn, spent 5 years as a junior faculty at University of Washington, was for a time at the Brookhaven National Lab. But for the last 32 years, I've been at the University of Delaware in the Department of Physics and Astronomy.
Excellent. Well, now, you are here on campus and have been on campus kind of this semester.
Right.
You're the president of the Society of Catholic Scientists. So tell us a little bit about the society, how it got started, what's its mission, and why are you here at Notre Dame, kind of those things all together.
Well, I'd long thought that it would be a good idea to have an organization of Catholic scientists, partly to show the world that there are a lot of Catholic scientists. There are a lot of religious scientists. But the actual impetus to do it came in 2016 when a very eminent scientist who is a convert to Catholicism was mentioning that his pastor had been suggesting that he start one. And I said, well, I've been thinking of that for years. So he said, why don't we do it together? So in the summer of 2016, we started from scratch this organization, the Society of Catholic Scientists, and we now have, I think as of today, 1,140 members in at least 45 countries, though most of them are in the U.S. at the moment. We hope to expand throughout the world. So it's grown quite rapidly, and I'm here at University of Notre Dame visiting the McGrath Institute for Church Life because they have a very exciting program, a science and religion initiative. And I work a lot with them, and we have a sort of partnership. So our permanent headquarters of our physical headquarters are going to be at Notre Dame from now on.
Wonderful. What's the mission of the society?
Well, the mission, it's a fourfold mission, actually. So the first is fellowship among Catholic scientists. This is very important because when you go into the academic world, not just science, you often people keep their personal beliefs quiet, especially if they think that they might be out of step with most of the people around them. And so as a result, and this happens frequently with religious people, and as a result, many people who are Catholics or religious in the academic world, in the scientific world, are unaware of each other's existence, so they feel isolated. It's not that you face hostility for the most part. What you face is a sense of isolation because you think you don't know that there are others out there who are also have faith. So fellowship among Catholic scientists is our number one mission. Second is witnessing to the world. That you can be a person of faith, you can be a devout Catholic, and also be a scientist. And then we also want to be a forum for discussion among Catholic scientists not just among ourselves, but with theologians and philosophers about science, faith issues. And the fourth is to be an educational resource for the world, for lay people, for journalists, for pastors, for Catholic high school teachers, and so on, about science, faith issues.
Wonderful. What of the makeup of the society? are there groups that are very well represented and others that are underrepresented?
You mean demographically or types of science by field?
Types of science.
Well, we are for natural science now, so we don't have social scientists. So natural science will include the life sciences and the physical sciences. Mm-hmm. We also include math, and we include computer science, computational science, and any fields that are closely related. So biomedical research, some engineering if it has a basic science component to it. But basically it's natural science rather than social science. We're pretty much equal. My sense from looking through our member directory is that we're probably roughly balanced between the life sciences and the physical sciences.
Pretty good for a group that just started 3 years ago.
Just started 3 1/3 years ago. And we're continuing to grow rapidly, and we haven't even really begun to expand significantly in Europe and Latin America and Asia. 80% of our members are are U.S.-based people. I think that we will multiply our membership several times once we start having activities in other parts of the world.
Now, have you done conferences or meetups?
We have an annual conference. Our last one was at Notre Dame, as a matter of fact. Okay. Our first was in Chicago, then at Catholic U. And our next one is going to be, our 2021 is going to be at Providence College in Rhode Island. But we're hoping to start having conferences at some point in Europe, as I said. And there's going to be regional chapters we're starting to set up. And hopefully there'll be smaller regional conferences, too.
Wonderful. Well, let's delve a bit into the relationship between science and faith. Mm-hmm. Many people believe that there's kind of a real battle between the two, and that faith is fighting itself a rearguard action. As scientists continue their research into processes and makeup of the physical world, they're able to explain things that maybe to our predecessors would have been considered miraculous, and thereby kind of undermine people's faith. Is that a fair assessment of the situation?
Well, there certainly is a battle going on. It's not really between science and faith, though there's a widespread perception that science and faith are opposed, that they're somehow in conflict or in tension with each other. But that's really not the case. It also has not historically really been the case. There's a lot of misinformation about scientific history. What people don't realize is that most of the great scientists from the beginning of modern science back in the 16th century up until relatively recently, up until, say, late in the 19th century, most of the great scientists were religious. I mean, if you look at the great figures of the scientific revolution of the 1600s, whether it's Kepler or Galileo or Descartes or Pascal or Boyle or Newton, and all the great figures were devout Christians. So the idea that there has been this war between science and religion for centuries is nonsense. Now, it's true that in more recent times, in the last century and a half especially, there's more unbelief appears among scientists, and there are many reasons for that. But it's not really because anything science has discovered is contrary to the faith. As far as science explaining things that might have been considered miraculous, an important thing that people should realize is that the reasons people historically believed in God were not miracles. The evidence of God, if you go back to the early Christian writings, what the church fathers and theologians pointed to as the evidence for the existence of God was not the miraculous. It was the orderliness of nature. It wasn't things that were contrary to the laws of nature or were outside of the natural order. It was the order of nature itself. It was the lawfulness of nature that pointed to God, because if there was a law, there was a lawgiver. In fact, if you look at the miracles of Jesus, Jesus did not perform miracles, nor did Moses, but Jesus did not perform miracles to convert atheists to believing in God. All the witnesses of his miracles were devout Jews who already believed in God. So that wasn't the function of the miraculous, as it were, in salvation history, is not to be evidences of the existence of God. As I said, the evidence for the existence of God is the very fact that the world is orderly and lawful. And the fact that it exists at all. So, and what modern science shows us, as it proceeds, it's showing us ever more clearly how orderly nature is. We now see the lawfulness and orderliness of nature at a far deeper level than was ever known before. So, in fact, the argument for the existence of God is ever stronger because of the discoveries of science.
Is it a lack of evangelization?
Well, I think yes. I think that's part of the problem. That is, I think there has been not enough done to first of all, to evangelize the culture, to explain to people who are not Catholic or not religious believers, to tell them about the history of science and how to think about the relation of science and faith. But also within the church, I don't think there has been enough catechesis. Mm-hmm. So I guess both on evangelization and catechesis, there has not been enough. Now that's changing. I think there's now a number of initiatives. Well, the Society of Catholic Scientists is one, but the McGrath Institute for Church Life at Notre Dame, its Science Religion Initiative is another. But the bishops are aware of this issue, and I think we find more and more. Bishop Barron is doing things about on science and faith, and so are other groups. So I think things are going to get better in this regard.
Well, now, you wrote a 2018 essay for the Church Life Journal, which is also out of the McGrath Institute, our friends there, explaining that in physics there's a type of modeling of the real universe. And you wrote, quote, "In physics, one must often make what are called simplifying assumptions. Mm-hmm. It is necessary to do so because real physical systems are far too complex to study exactly," end quote. Now, this model that is proposed by physicists is theoretically infinitely perfect, though as you go on to explain, that perfection can itself be a limitation because of our limited ability to measure and even comprehend the infinite factors that make up any given real-world object. You talk about a billiard ball. Mm-hmm. We model a perfect billiard ball, even though a real one may have scratches and things that would affect its real world kind of existence. Now, as I was reading this essay, I was reminded of the problem of analogy that figured so heavily in medieval theology. The idea that when humans try to explain something about God, no matter how lofty the language we use, the difference between what we can say and what God is really like is itself infinitely vast. Is that an apt similarity for the idea of the ideal world modeling that's done in physics and the language we use in theology?
There's some analogy there. I would hasten to say one thing, and that is I would distinguish between the ultimate laws of physics, whatever they may be, and most physicists in my field, believe that there is some set of ultimate laws of physics. That's the whole. Those are the laws of physics. We haven't yet found them. Or we're not sure we found them. And those, I think, would be exact. That is, not just approximations to the world, but they would be an exact mathematical description of the physical world. But in practical terms, when you're trying to describe any actual concrete system, even something like a billiard ball, even a single atom, there's so much complexity there that as I said, you have to make simplifying assumptions, and so in reality, no human being can have a complete and accurate and perfect description of anything in the world around him, because the world is far, far too complicated. And I suppose you could say there's an analogy there, that just as the actual concrete physical world is far too complicated for us to have a perfect description of it. We cannot have a perfect idea of God. Though with God, the reason we have to use analogies is that God infinitely transcends our categories of thought. God is not a creature. All we have direct knowledge of is creatures or things that God created. They're finite, and so our concepts, which are entirely based on created things, cannot aptly, correctly grasp the divine essence, because God is infinite. There's actually even a better analogy from the physical world, I would say. As we get deeper into physics, we're getting down to things with which we have no everyday experience. So if we talk about subatomic physics, which is my field of physics, there are things go on at the subatomic realm which are very counterintuitive. Quantum mechanics is notoriously counterintuitive. Yeah. You never, though we have very good equations and we can calculate things to fantastic accuracy, at the gut level, no one really has an intuitive, really gut understanding of quantum mechanics, because the concepts required are so alien to our everyday experience. And so, but nevertheless, they're still about finite things. Whereas with God is not only alien to our experiences, we but God infinitely transcends any experience that we could ever have. And so, so there's a limitation.
Yeah. While reading the essay, I will confess my brain was completely torn apart because, I mean, you're talking about quantum, what a field of energy, and then particles being created in pairs.
Well, yeah, the basic language of our current theory of physics is something called quantum field theory. So, this is our current level of understanding. So there's sort of the basic things or entities in the world are quantum fields. Think of electric fields, magnetic fields, gravitational fields, and so on. And so when you do things at the quantum level, you're talking about quantum fields, and they're very interesting and mysterious and do funny things. So yes, you can pop out of seemingly empty space a particle and an antiparticle, or the particle and the antiparticle could, quote, annihilate into various other things. So there's strange goings on in in this physical world of ours.
Yeah, and yet, like you say, it's still, because it exists, it's still finite.
Everything, it's finite. I mean, I'm not talking about finite in the sort of size. It could be, as far as anything we know, the universe could be infinitely large. But they're finite in a different. God is infinite in a different sense, not in the sense that He is infinitely large, but that He is transcends our categories of thought. So anything we say about God, as the great theologian said, anything we say about God falls short. It can only be true in some analogical sense. Yeah.
Well, now you've made reference to your own field of study, your own field of research and stuff. Tell us a little bit about what you actually do study and do research on. You list particle physics, particle cosmology, grand unified theories. There are laws that have your name in them. So tell us a little bit about these things. Right.
So I'm in a field called, I am retiring from active duty as a professor actually in January to devote full time to the Society of Catholic Scientists. I'm about to turn 66, so it's not too early to retire.
Congratulations.
But I'm going to be working harder in retirement than ever before. But when I was doing active research until a year or two ago, my field was I had several major areas I worked in. One you mentioned, grand unified theories. Those have been around since the early 70s. They're mathematical theories which give a unified description of the three known non-gravitational forces. And there's a lot of circumstantial evidence that these three non-gravitational forces are all deeply connected. In fact, they're fragments, if you will, remnants of what at a deeper level is a single force, hence the name grand unified force. And so I've written a lot of papers on that, and a couple of them are quite well known. I also work on something that sounds esoteric. It's called CP violation. That actually has to do with the fact that nature almost treats particles and antiparticles symmetrically, like they're mirror images of each other. But there's actually a slight asymmetry there. Nature doesn't quite treat them exactly symmetrically, and that's called CP violation. And that's very important, actually, because if nature treated particles and antiparticles exactly symmetrically, we wouldn't be here, because all the particles and antiparticles would have existed in equal numbers and would have annihilated, and we wouldn't be left. There would be no matter left to make things of. So it's a very important subject in particle physics. So I've done work on CP violation and what I just mentioned, which is called baryogenesis. That is, how was it that in the early universe matter got the upper hand over the antimatter so that there's more matter around, so that there's stuff left to make planets and people and so on. That's called baryogenesis. And the third thing, I guess, you mentioned well, there's other things I work on too. It's not understood. There are a lot of particles in our standard model of particle physics, and they have various properties. They have their own, each particle has a mass. Nobody understands the pattern of masses of the fundamental particles. There's clearly the patterns there, but no one understands them. And I've done a lot of work on trying to understand why different particles have the masses that they do.
Would you say that your work in research and doing these kinds of things, what effect do they have on you, Steve Barr, the man of faith?
Well, they don't. I would say, if anything, they strengthen my faith. Though my faith, as I said, to the extent that the natural world gives a motive for faith, it's on very basic grounds. The reasons to believe in God are not found in telescopes and test tubes. I mean, because 2,000 years ago, there were reasons to believe, and 1,000 years ago, there were perfectly adequate reasons to believe before people knew any science. But when you see the lawful, how beautiful, how deep the laws of physics are. In my field, we're dealing with the question of what are the deepest laws of physics. That's the name of the game in particle physics. What are the deepest laws? And the laws that we have unearthed, especially in the 20th century, are so profound mathematically. The equations are so sophisticated, beautiful, harmonious, that one appreciates that they're the work of a great mind. That as I say, the universe wasn't put together with Tinker Toys or Legos. The architecture is of incredible mathematical depth, and that suggests a mind at work, a very deep mind. Of course, an infinitely deep mind, we know as Catholics. But in that sense, I'm constantly put in awe of the world that God has made. And I should say that's the traditional attitude. Back in 400 years ago, the great scientist Kepler, one of the first modern scientists, was a devout Lutheran. He said, "I thank thee, Lord God, our Creator, that thou hast allowed me to see the beauty in thy work of creation." That was the attitude of scientists for hundreds of years. And it's still the attitude of many today, and it's the attitude of all the members of the Society of Catholic Scientists. In fact, our motto is, I think, research with wonder, knowledge with devotion, or something of that sort.
Yeah. Wonderful. And I know that you also, did I read about an award, the St. Albert the Great?
Yes,
award?
we at our annual conference, we give an award every year, the St. Albert Award. Last conference, our third, we gave it to Maureen Kondik of University of Utah, who's a neuroscientist and
great friend of the center. She's one of our Vita Institute professors.
Right, she is a great friend of the CEC. And the year before that, we gave it to Juan Maldacena, who's a member of our organization, who may be the greatest physicist of his generation. He's at the Institute for Advanced Study in Princeton. In fact, he's in my field, particle physics, and he wrote a paper 22 years ago that is the most highly cited paper in the entire history of theoretical particle physics. So he's a giant, truly a giant in the field. He's up there on the level with Hawking and people like that. He's in that league.
Wow.
So, and he's a member of the Society of Catholic Scientists and was gracious enough to accept the award and give a talk at our second conference. So, and next, so we're giving an award at our next conference to a professor at Johns Hopkins named Lawrence Principe, who's a chemist but also a very well-known historian of early modern science. So we have an embarrassment of riches. There are a lot of good people out there we can give the award to.
Wonderful. Well, now, so for those of us who are laymen, what are some good resources for interested layperson who might be interested in learning more about the relationship between faith and scientific reason? Okay, well, there's a whole bunch of things I could mention. I'm going to be egotistical and say, well, if you are in science, I've written a book that is it's actually aimed both at professional scientists but also at the scientific layman. And it's called Modern Physics and Ancient Faith. If you have a relative or a friend who's a scientist and wants to understand what religion is all about, this would be a good book to give them. Another book I wrote, which is a collection of essays, is called The Believing Scientist. Another book, which I cannot recommend too highly, is by Christopher Baglow, who is here at Notre Dame. He's the head of the Science Religion Initiative here at the McGrath Institute. He wrote a book which is actually, I believe it is now coming out this month in its second and a much revised edition. So the title, I think, is, I may get it wrong, Faith, Science, and Theology, something like that. But his name is Christopher T. Baglow, B-A-G-L-O-W. That is the first, and as far as I know, the only book ever written as a textbook on science and faith for Catholic schools. So it can be used in Catholic high schools, but also even at the university level. It's a brilliant book. Everyone should go out and get a copy of that. We're trying to put more resources on our Society of Catholic Scientists website. Which is,
well, just if you Google Catholic and scientists, you'll find us, but it's www, and then all one word, CatholicScientists, plural.org. And as in the next few months, we're going to be putting up some educational material there. There are books by non-Catholics that I would recommend. There's a book by Francis Collins, who's, though he's not Catholic, but his theology is basically Catholic. And he's a very eminent scientist, and that his book is called The Language of God. And it explains how it is that he, as an adult, became a believer. I warn you that the appendix has some bioethics that's not acceptable from a Catholic point of view, but who reads appendices? The book itself is a terrific book. And there's a lot of good books out there. Yeah.
One last question. Are there some emerging areas of scientific research that a person of faith might keep an eye on?
Well, I probably not that a person of faith has to keep an eye on, a fearful eye on. One thing that Catholics should realize, religious people should realize, don't live in fear that science is about to discover something radical, revolutionary that's going to overturn the apple cart. Suddenly all the reasons to believe in God are gone. They've explained why the universe exists. They've shown that we have no free will or whatever. You will read articles in the media that are hyped. Anything you read in the science media, if you want to know how important the discovery actually was, divide by 10, because there's an enormous amount of hype. The whole thesis of my book, Modern Physics and Ancient Faith, was that actually I list 5 of the really great discoveries in the 20th century, brought our picture of the world closer, much closer to a traditional religious view of the universe and our place in it than the scientific picture had been before the 20th century. So don't imagine that science, every discovery leads us away from faith. Some of them may appear to do that, because the road of scientific discovery is a winding road, and at times the road seems to be veering away from what we believe as Catholics. But you should be confident that in the end, the road will lead back, and it has in a number of major areas. When it seemed to be moving away before the 20th century, actually changed course. And right now, I can't think of any areas where I'd be worried about anything. But
wonderful. Well, that is a great positive message of hope, though, too.
Yeah.
Wonderful. Well, Steve Barr, thank you so much for coming to be with us, and thank you for the work that you and the Society do.
Well, thank you, and thank you for all the work that the CEC does.
Thank you to Steve Barr. You will find links to his book and the others that he suggested, as well as a talk that he gave on the myth of conflict, in the show notes. Subscribe to Ethics and Culture Cast so that you can always get the latest episodes by visiting ethicscenter.nd.edu/podcast. We would love your feedback. Please review the show on iTunes, Google Play, or wherever you get your podcasts, and email your suggestions to cecpodcast@nd.edu. Our theme music is I Don't Know by Grapes, licensed under the Creative Commons Attribution License. We'll see you next time on Ethics and Culture Cast. Until then, make good decisions.